All right, so part 2 of section 1.6. We've been talking about transformations, and today we're going to focus on the reflections over the x and y axis. And we're also going to talk about what happens when you do a reflection through the origin. And then we are going to start combining transformations. So we're going to take our translations from section A and combine them with our reflections from this section and do both at once. So just a reminder to you of what transformations are. They are changing the shape and or location of a parent function. So we're going to be moving graphs up, down, left, or right. That's a translation. We're going to flip things over, which is a reflection. And then you have dilations, which is going to change the size of a graph by doing some vertical and horizontal stretches and tricks. So let's get right into what happens with a reflection. If we are to start with a coordinate over here in the first quadrant, so I have the coordinate of xy. If we wanted to reflect that coordinate over the x-axis, what's going to happen here is it is the same distance, perpendicular distance, over that x-axis. So right here, the fact that I'm 4 units above the x-axis, I'm going to reflect it 4 units below the x-axis. Now, a lot of times people always think, okay, the x value changes, when actually it's the opposite. Your x value is actually staying the same because you're not moving it left or right. You're moving this point actually straight down. So it's your y value that now becomes the opposite. So that's the big change that we need to think of when you're doing a reflection over the x-axis. When you move over to a reflection across the y-axis. So here's our y-axis, which is running vertical. When I reflect it here, notice I'm going to use the perpendicular distance. I'm 1, 2, 3, 4, 5, 6 units away. Well, then I'm going to go 6 units to the left. And again here, what's happening is your y value is actually staying the same. It's your x that's changing to be the opposite, because you're moving your point actually straight to the left. And then we have what's a reflection that is through the origin. And a reflection is through the origin. What that's doing here is saying, okay, how far are we from the origin? And then we're going to travel that same distance through the line here. And in our case, grab this, if I went up, let's see, 1, 2, 3, 4, 5 units, and then I think I counted over 6 before. Well, now I'd have to go down 5 units, and I would have to go to the left 6 units. And then this point right here is going to give me my reflection through the origin. And what ends up happening here is your x and your y become opposites, and they both become negative. When you do a reflection through the origin, you are actually doing a reflection over the x-axis and over the y-axis. You're doing both of those to have a reflection that's through the origin. Therefore, both the y and the x are becoming opposite of what they were. So just to kind of replay all of this, so if we wanted to reflect something across the x-axis, let's say we take the point of, let's go -3, 5. If I reflect that point over the x-axis, your x value will stay the same and your y value is going to become the opposite. If I take that same point, -3, 5, and I want to reflect it across the y-axis, your x value is going to become the opposite, so +3, and your y value is going to stay the same. Through the origin, if we have -3, 5, if I reflect that, our x value is going to become the opposite, and so is our y value, so now we get 3, -5. So there's our reflections through those 3. Now let's take a look at what happens when we start looking at graphing them out on our calculator. So I started out with a parent function that's been moved to the left 2 units. So I have the absolute value of x plus 2. And what we're going to see is what happens when we change things around a little bit. So here's my graph of x plus 2. I'm going to go ahead and plug that into my calculator. So absolute value of x plus 2. And there's our function that you can see here. Now I'm going to go into y2, and we're going to see what happens when I put a negative out in front of the absolute value. And then we type in x plus 2. When I hit graph here, what you should be seeing is that we are having a reflection, and it's being reflected across over the x-axis. So all of our x values are staying the same. It's our y values that are becoming the opposite. And if you think about that, you know, this is all of our x, and then that negative being outside, that's what's changing everything over. So you can probably guess what's going to happen on the next one. I'm going to go ahead and just delete y2 so we can see it. And I'm going to go math. I'm going to go ahead and hit the absolute value. And I'm going to go with negative. And actually, I don't want those parentheses there. Sorry. So get rid of those parentheses. I just want negative x plus 2. So negative x plus 2. And graph that out. Here's my first graph. And what's happening here is, even though it looks like it's just moving over 4 units, it's actually being reflected over that y-axis. It's the same image. Okay. So there we are. So you have inside and outside change that are taking place. And when you have a outside change, so you have a negative f of x, you are going to reflect that graph over the x-axis. When you have inside change, and that means taking the x that's inside your function and making it negative, you're going to end up doing a reflection over the y-axis. If you do both, so you have an outside change and an inside change, you're going to be reflecting your graph through the origin. So let's go through just a couple examples to help you understand what's happening. So I'm using very similar to the same functions that we had in lesson A. The first one, we have function f of x, so we have the ln of x. What we're going to be doing here is we want to reflect it across the x-axis. When we want to go with the x-axis, we want to have the outside change that's here, so we want to make that a negative. So we're going to take this function f of x, and I'm going to make this negative the natural log of x. The outside change is what's going to give us a reflection across the x-axis. With the g of x, if we want to reflect it across the y-axis, we're going to use inside change. So I'm going to take the function g of x, and we're going to be taking in parentheses negative x, and we're going to be squaring that. And that would be a reflection across the y-axis. And the last one, we want to reflect it across the origin. So that means that we have two things that are taking place. We have to do the outside change as well as the inside change. With this function that we're working with here, this is your function f of x. That minus 3 that's taking place, that's telling us that we're going to move that parent function down 3 units. So when you're working with your function here, we want to make it taking the negative of the function. We don't have to worry about the minus 3 here. So we have to do both inside and outside change. So our function of wx is going to become negative e to the power of negative x plus 2, and then all of that being subtracted by 3. So I have both inside and outside change that are taking place with the function w of x. If I take a problem here where I have some different transformations that are taking place and trying to work backwards, you kind of want to look to see, what do we have, inside or outside change. And for t of x, the fact that x inside my absolute value is positive, I do not have the inside change, but I do have the outside change, which is this value of x, which means that we are doing a reflection across the x-axis. If I were to take away that problem, my parent function that we'd be working with here is t of x. You could think of it here as being the absolute value of x, but with the transformation that we are using here, I'm going to say that t of x is equal to the absolute value of x plus 4 plus 2. So we did a reflection, and it's been translated as well. In the next one here, you have inside change because that x is negative, which is inside the parentheses. So that's our reflection across the y-axis. And its parent function would start out, if there was nothing taking place to it, we'd have the sine of x. And because we have, we've moved this, let's see, we've moved it to the left 3 units. I'm going to go ahead and just say its parent function is the sine of the quantity of x plus 3. So now hopefully you're kind of understanding what's happening as far as with the reflections. And through these last 2 examples, you're seeing maybe that there is a lot more that's going on, that can be going on. So let's just take a look at one final example where you have a parent function of k of x, and we want to describe the transformations that are taking place. So from here, the fact that I see that, first of all, you've got, it's a function, so this is really difficult notation for some of us to see. But here's our function k of x. And this -5 right here, this is what's going to tell us that our function's going to be moving down 5 units. The inside change of +4 is actually telling us that our function is moving to the left 4 units. And then you have this, get a different color here, you have the negative that's out in front of your function. And so that's telling us that we're doing a reflection over the x-axis. So we have 3 things that are taking place to this function k of x. We have a reflection over the x-axis. We have, we're moving the graph over 4 units, and we're moving it down 5 units. So I just kind of want to take you back to the graph. Let me see where I'm at time-wise. All right, I got just a couple minutes. Just to kind of show you what's happening. I'm going to take a graph that works really well for being reflected over the x-axis, and we're going to take the cubing function, so x to the 3rd power. Okay, so there's my graph. Now let's see what happens when we use this graph and we plug it in. So into y2, I'm going to put negative, and then in parentheses, I'm going to take x plus 4. I'm going to close my parentheses, take it to the 3rd power, and then I'm going to subtract 5. Now, if everything went as planned here, we will see a reflection over the x-axis. We'll see this graph that's moved over to the left 4 units, and we're going to see it move down 5 units. So let's cross our fingers. All right, so what I'm going to do here is I'm going to take a picture of it just so I can paste it on the screen here. There we go. All right, so, oops. When you look at this graph now, I'm just going to get a little larger. When you take this graph and you look at the parent function, okay, here's my parent function. Now, if I was to reflect this over the x-axis, what's going to happen is I'm going to end up with this green graph that I have right here. Notice that's what's happening down here. Now, this point of 0, 0 is being moved to the left 4 inches, or not 4 inches, 4 units, and it's moving down 5 units, and that's where we're at now. So this graph now is the same thing. It's a reflection over the x-axis. It's been moved over to the left 4 units, and it's moved down 5 units. I know that this can be real challenging once you start adding things together. So if you have any questions, you need to be sure to write them down and bring those up in class tomorrow. So we made it under 15 minutes, so that's it.